Okay, so today is St. Patrick's Day, so that's why I'm writing in green. We're going to be looking at log functions as inverses, so we're going to be using your knowledge from what inverses were. We did them a couple weeks ago with exponential. No, we didn't do them with exponential. We did them with quadratics and square roots and just linear functions. And then we're also going to be using what we did yesterday to help us. So first example, I want to find the inverse of the following function. Y equals log base 5x. So if you recall, when we did inverses before, the very first step that we did was we switched our x and y. So we're going to do that same thing here. Switch the placement of x and y. So where x is, I'm going to write y. Where y is, I'm going to write x. So here I have log base, or x equals log base 5y. Now that we started off with log, to find its inverse, that means I'm going to go to exponential. So now I'm going to use the information from yesterday to change to exponential form. So if you recall yesterday, the base of the log is also the base of the exponent. So I'm going to have 5 to the x power equals y. And also you should recall when we did inverses, our final answer was written with the f inverse of x. So f inverse x equals our function, 5 to the x. So log base 5x is the inverse to 5 to the x power. All right, so let's look at another example. I have y equals log x minus 3. All right, on this one, if there's not a base written, hopefully you remember that it's base 10. So I'm going to first switch x and y. So I'm going to have log, or x equals log, I'm going to go ahead and write that 10 there, y minus 3. And since this y minus 3 in parentheses, it's fine. It's all one thing. If the minus 3 was on the outside of the parentheses, then I would have to move it first. So here I'm going to rewrite it in exponential form. So I'm going to have 10 to the x power equals all of this y minus 3. Okay, and then I guess that third step that we didn't write because we didn't have to on last time is to solve for y. So if I want to get y by itself here, I'm going to add 3. So I have y equals 10 to the x plus 3. So again, I'm going to write the inverse function is 10 to the x plus 3. All right, let's see the next one. We have y equals log base 3x. So again, that 3x, we could consider it being in parentheses, so it's all one thing. So when I rewrite it, I'm going to switch the x and y. Change it to exponential form, so the base of the log is going to be the base of the exponent, x equals 3y. All right, and then here I want to solve for y, so I want to get y by itself, so I'm going to divide by 3. So the inverse function, this actually can be reduced more since these are the same base. What is the exponent on this 3? It's a 1. And if you recall when we're dividing, so 3x over 3, 1, that's going to be equal to, let me scoot this over so you can see it, 3 to the x minus 1, because of your dividing exponent rules. So really my final answer will be 3 to the x minus 1. If you left it like 3 to the x divided by 3, it's not wrong all the way, but it's not simplified as far as possible. So I want you to try to simplify as far as possible. All right, let's see. Now we're going to look at going from exponential to logs. So if I start off with exponential, again, I'm going to switch x and y first. So here I would have x equals 4 to the y minus 3. And then now we'll change it to log form. Okay, you have, in this case you have to get the exponential part by itself, so I have to get the 4 to the y by itself. But, so get x part, exponential part by itself, and then change to log form. Alright, so exponential part by itself, so that means I need to get 4 to the y by itself. So for me to do that, I need to add 3 to both sides. So now I have x plus 3 equals 4 to the y power. And now I need to rewrite this in log form. So this entire x plus 3 is its own thing. So I need to make sure I put that in parentheses. So the base of the log will be the base of the exponent, then what it equals, and then the exponent. So the inverse is log base 4 x plus 3. Alright, last example. Hopefully this is making sense. If not, ask questions. Alright, on this one I have y equals 3 to the x plus 1. So the entire x plus 1 power is in the exponent. So again, switch x and y first. The exponential part is by itself, so I don't need to do anything more to this except for change it to log form. So I'm going to have log base 3 of x equals the y plus 1. Alright, so that fourth step that we didn't have to do on example 4 is the solve for y. Because y was already solved for on that one. So for me to solve for y in this, I'm going to subtract 1. So the inverse is equal to log base 3, and I'm going to go ahead and put that x in parentheses so you can see the difference between those two, minus 1. So parentheses are important because this one, if you remember when we did transformations of our parent functions, this one moved our graph left and right, this one moved our graph up and down. So your assignment for this is a worksheet, so that will be passed out and you have the rest of class to work on it. Hopefully you already turned in your A1 through A3. I'm hoping to be back on Friday. If not, then I'll see you on Monday. I don't think I'll be back any earlier than that. But be good as always. Thank you. Bye.